Hello everyone, and welcome to my channel. This is an educational channel. We focus on different theories of everything, all-encompassing theories, magnum opuses from obscure authors, ancient and modern, and we try to showcase things that you may not know about, but you'd be glad you did if you do. And today is our 383rd video that we've done on Dewey B. Larson and his reciprocal system of theory. And Larson was an American engineer who lived from 1898 to 1990. And during his life, he was trying to work out some fairly mundane chemistry problems and stumbled across a solution that had much wider application. He stepped up to the plate, and for 25 years he did a lot of unpaid, unnoticed research into without giving up his day job, and into the nature of his findings. And eventually in 1959, he put out his two fundamental postulates, outlining basically how the universe operates. And then over the next 30 years, he went through a process of deduction, if this, then that, to arrive at a theoretical universe. If the universe operates in the way that I say it does, these are what the consequences are going to be. And then in his books, he compared those consequences with the actual observed consequences that the scientists had measured and compiled in their tables. So, for example, he has a book called Basic Properties of Matter that we will be going over pretty soon, where he takes the periodic table along with a lot of compounds, and he predicts what their basic properties would be, such as their melting point, or their specific heat, or their compressibility. And then he compares those with the actual scientific tables that have been published. The conclusions that I come to from looking at that is that either Larson has the right formula for how the universe operates, or he's fudging the numbers because he's so close to the given values that he has to be onto something, or else he's just a fraud. And just from reading his work, I find it very hard to believe that he's a fraud. I can't tell for sure. I'm not a scientist. I'm a liberal arts person, a history person. And so, you know, there may be some tricks that he has that I don't know about, but I actually believe that he was onto something. And so I'm trying to spread this out. Larson's first postulate, which is his most important of the two, is that the universe is composed of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. The second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Now, I'd like to set aside that second postulate, as it is not as important, and it has been disputed by some of Larson's followers, including me, who think that Euclidean geometry is not the whole story. Euclidean geometry is certainly in operation in some parts of the universe, but in other parts there may be more inclusive geometries that apply, such as projective geometry. We talked about that when we were talking about some of the writings of Dr. Bruce Perret, who's one of Larson's chief revisers since Larson died. And he also has a problem with the commutative mathematics. But the first postulate, which I do have some issues with the first postulate also. I think that instead of using the term motion, Larson might have wanted to use the term scalar motion. Actually, when he originally put together the postulates, he used the term space-time instead of motion. And toward the end of his life, he used the term change in 3 dimensions. So the postulates were not set in stone. He revised the postulates several times during his life. So it's difficult to, quote them. But I think I just gave you the first version of the Oh, no, not the first version. I'm not sure what version I've given you. But the basic gist of it is still the same, which is that the universe is made out of motion, in particular, a kind of motion called scalar motion, which is a motion that has a magnitude but has no directions and can be envisioned using a balloon with dots on it. If you blow up the balloon, all the dots are moving away from each other. If you suck in the balloon, all the dots are moving toward each other, but they're not moving in any specific direction. Each one is moving away from each other one. And so the universe is composed of, not matter, not energy, not force, but motion, in particular scalar motion. And scalar motion in general, is the relationship between space and time. That sets up a generalized relationship between space and time, a reciprocal relationship. And as all reciprocals, space and time have the same qualities, but they have them in reverse order. And space and time, neither one of them exists in reality. They only exist together in motion. And motion is basically a fraction with space or time as the numerator and time or space as the denominator. Space and time both can be in multiple dimensions, and all of our scientific quantities are relations between space and time, such as speed, space over time; energy is time over space; acceleration, space over time squared; matter, time to the third power over space to the third power; pressure, time over space to the fourth power, etc., etc. And time and space both really have 2 fundamental primary aspects. One is the scalar motion. Larson calls it clock time and clock space. The clock is always getting later and later and later and later, but in no specific direction. And space is always getting farther and farther and farther apart, but in no specific direction, which was actually observed by the legacy scientists looking through their telescopes, that all of the distant galaxies are moving away from each other. And space and time both also have what Larson calls a coordinate aspect, that is a stationary 3-dimensional aspect, such as we observe in our normal world, space and time as volume, or space as volume, XYZ coordinates in a stationary field. Larson also posits, therefore, as part of the reciprocal postulate, that time also has its stationary aspect, 3 dimensions of time. And then also time and space both have their discrete units. there's a minimum unit of space and a minimum unit of time. If you don't have a full unit, you don't have anything. So you have to have a full unit of both space or time and motion in order to have anything. And if you have exactly 1 unit of space in 1 unit of time, you have the speed of light, which is what Larson calls unit speed. 1 over 1 equals 1. And unit speed is the background motion of the universe of motion of Larson, meaning that when you have absolutely nothing in the universe of motion, you still have the speed of light outward in all directions. And that is what Larson refers to as the progression of the natural reference system, also the state of rest, or the ether, the origin, the reference point. And that is the point from which Larson makes his measurements, as opposed to the legacy scientists who make their measurements from 0. But that's the characteristic of a reciprocal system. If you have an additive system, you add or subtract from 0. But if you have a reciprocal system, you're multiplying. And all our reciprocals multiply to be 1. And on one side of the ledger, you have 1. You have 1 in the middle. You have 2, 3, 4, 5 on one side, and on the other side, you don't. In legacy science, you would have -1, -2, -3, -4, -5, or not -1, but 2, 3, 4, and 5. But in the reciprocal system, you have 1/2, 1/3, 1/4, and 1/5. Then you never get to 0. That would be 1 over infinity. And so this also flies in the face of legacy scientists who say that the speed of light is the maximum speed of the universe. Larson says that the speed of light is the midpoint of the universe, and that half of the universe is moving faster than the speed of light. It's what we call the cosmic sector, and the half that's moving slower than the speed of light, Larson calls the material sector. The material sector is really the only sector that legacy scientists know anything about, but they could figure out the cosmic sector if they just extrapolate and reverse the order of space and time. So in the material sector, you have coordinate space, 3 dimensions of stationary space, and you have clock time. The clock is always getting later and later and later. In the cosmic sector, you have coordinate time, 3 dimensions of stationary time, and you have clock space. Space is always getting farther and farther and farther apart. Okay, now we are in the 5th installment today of going over Larson's paper, How Much Do We Really Know? And this paper, so you go back 4 episodes if you want to start at the beginning. We're starting here in the middle toward the end. And this paper is really like a history of science, going over really legacy science and demonstrating that even though they have a very enthusiastic view of what they've accomplished over the years, that really, when you really get down to it, the scientific establishment doesn't really know much. They have a lot of hypotheses about things, but when they say scientists now know, they may not really know. And Larson has been going over point after point of where the scientific establishment claims to have knowledge about something, but they don't. And so we're going to proceed from here and see where he gets to. Okay, theories that conflict with known facts are not knowledge. The truth of this statement is self-evident, and it may seem superfluous to mention it, yet some of the most important items of present-day physical knowledge fail to qualify as such under this rule. For example, we know that positively charged particles repel each other with a force which becomes very great at short distances. On the basis of what we know, therefore, it is impossible for a number of protons to remain together in a unit such as the atomic nucleus. Likewise, we know that the neutron is unstable in the local environment, and on the basis of what we know, the existence of neutrons in a stable atom is impossible. This does not mean that the nuclear theory is necessarily wrong. There may be factors in the situation of which we are ignorant, but it does mean that the nuclear atom is not something that we know. It is a hypothesis, and one of a very dubious character. Yet the pressure for conformity to accepted ideas is so strong that the existence of the hypothesis is considered proof of the existence of some unknown force, a nuclear force, opposing the known force that would otherwise disrupt the hypothetical structure. The logical justification for this line of thought is certainly hard to detect. It may be assumed, however, that these conclusions have been influenced to a considerable degree by the impression that the existence of an atomic nucleus was proved by the early experiments of Rutherford, who showed that fast-moving particles pass through thin sheets of solid matter without interference, except in cases where they make direct hits on what is now identified as the nucleus. As a result of these and similar experiments, it has been concluded that almost all of the mass of the atom is concentrated in this relatively small region. But here again, we encounter the same curious failure to explore alternatives that has been noted earlier in this discussion. The experimental results are consistent with the conclusions that almost all of the mass is concentrated in a relatively small volume, to be sure, but they are equally consistent with the alternative conclusion that all of the mass is concentrated at this point. In other words, that this is the atom, not the nucleus of the atom. It seems to have been completely overlooked that while there is ample evidence of the existence of something massive at the center of the region in which the atom is located, there is nothing at all to confirm the existence of the hypothetical outer parts. The idea that the atoms are in contact with the solid state is pure guesswork. Indeed, the fact that the interatomic distance can be reduced very substantially by the application of pressure to less than half in some cases strongly suggests that the spacing in the solid is simply the result of a force equilibrium. The conventional diagram of the sodium chloride crystal found in most elementary chemistry textbooks may be a fairly accurate representation of the physical facts. The other mainstay of the present-day theory of the atom is the fact that electrons can be obtained from atoms, particularly as products of atomic disintegrations. This is the overriding point that has convinced the scientific world that electrons are the constituents of atoms, and has made it easy for any additional finding which is consistent with the nuclear hypothesis to be accepted as proof of its validity. The argument may be summarized as follows. Under certain conditions, atoms disintegrate. Electrons are found among the disintegration products. Therefore, electrons are constituents of atoms. At first glance, this argument may seem sound, and certainly it has been accepted without serious question. But its true status can be brought out clearly by stating the analogous argument concerning the photon. Under certain conditions, atoms disintegrate. Photons are found among the disintegration products. Nevertheless, photons are not constituents of atoms. Here we find that on the basis of exactly the same evidence, current practice arrives at diametrically opposite conclusions. Because preconceived ideas concerning the electron suggest that it could be an atomic constituent, the evidence from the disintegrations is accepted as proof that it is, whereas similar preconceived ideas concerning the photon suggest that it could not be an atomic constituent, and exactly the same evidence is therefore taken to mean that the photon was created in the process. Actually, of course, the physical evidence does not distinguish between these alternatives, nor does it preclude the possibility that some other explanation may be correct. What the evidence shows is that the electron either was a constituent of the atom or was pre-existing within, but not a part of the atom, or was derived from the surrounding space, or was created in the disintegration process, or originated from some combination of the foregoing, or had some other origin consistent with the evidence. The clear and positive picture of the atom set forth in the physics textbooks has long since been abandoned by the frontline theorists, as by this time it is evident that the concept of such a structure is untenable. What started out in the original nuclear atom, conceived by Rutherford and developed theoretically by Bohr as the identifiable and physically observable entity which we know as the electron, has now become a mysterious something which no one seems to be quite able to define. Heisenberg tries. The indivisible elementary particle of modern physics, he tells us, is not a material particle in space and time, but in a way only a symbol on whose introduction the laws of nature assume an especially simple form. It is nothing short of ludicrous to find our elementary textbooks explaining the present day knowledge of the structure of the atom in positive terms and in great detail, while at the same time Heisenberg and the Copenhagen School, who represent the official viewpoint, quote, official viewpoint of present day theoretical physics, tell us that the atom of modern physics can only be symbolized by a partial differential equation in an abstract multidimensional space. The statements commonly found in the textbooks, such as this one, quote, there is so much physical and chemical evidence for the correctness of the modern atomic picture that there can be no reasonable doubt of its validity, become nothing but absurdities. That's the end of the quote. Become nothing but absurdities when the modern atomic picture, explained in detail by the textbook authors, is flatly repudiated by the leading theorists in the physical field. The truth is that the physical and chemical evidence, which is given so much weight by these authors, is not actual evidence of the nuclear atom. It is evidence which is consistent with that hypothesis, but which is equally consistent with other hypotheses, and therefore is not a proof of any of them. Many physical and chemical phenomena, for example, are functions of the number of valence electrons, so-called, which the atom presumably possesses, according to the nuclear theory, and these relations constitute a major part of the evidence to which the textbook authors refer. But in these relationships, if these relationships are examined critically, it will be found that the electron, as such, plays no part in them. There are relations which involve only numbers. There's a typo here. I think it says, yeah, they are relations which involve only numbers. And whether these are numbers of electrons or numbers of something else is completely immaterial. We find, for instance, that Moseley's law relates the X-ray frequencies of potassium to the number 19. And this is taken as a confirmation of the hypothesis that the atom of potassium contains 19 electrons. But there is not the slightest evidence that electrons have anything to do with this situation. The relation is solely with the number 13 or 19. And any theory which leads to the existence of 19 units of any kind in the potassium atom is perfectly consistent with the experimental knowledge. Much the same kind of statement can be made about almost any experimental result that is now expressed in terms of the nuclear theory. The experimenters who are busily engaged in measuring nuclear cross-sections, for example, will probably be horrified at the suggestion that there is no such thing as a nucleus. But these investigators are measuring cross-sections, not nuclear cross-sections. The identification with the nucleus is theoretical, not experimental. And if the theory has to be changed, this does not affect the experimental results. It simply changes the language in which they are expressed. We just substitute atomic for nuclear, and everything else goes on just the same. The prevailing impression that the huge mass of experimental information of this kind accumulated in recent years constitutes evidence of the validity of the nuclear theory is entirely erroneous. Summarizing the foregoing discussion, it is not necessary to assume the existence of an atomic nucleus to explain the results of Rutherford's experiments, and Occam's principle, one of the sound common sense rules of science, tells us that we should not make unnecessary assumptions. Furthermore, the fact that electrons can be obtained from matter as a result of disintegration or other processes is not a proof that the electron is a constituent of matter, nor does it even prove that the electron existed prior to the event that caused it to appear. This demolishes the two primary arguments in favor of the nuclear theory, the arguments which have been relied upon to offset the two definite and positive conflicts between this theory and known facts. At this point, therefore, it would appear that the nuclear theory is not only unproved, but it is actually disproved. The question then arises, must the entire electrical theory of matter be discarded? But when we remember that the electrical theory antedated the nuclear atom by about 100 years, it is evident that this theory is not tied to the nuclear hypothesis. It simply goes back to where it was before Rutherford. However, this does not necessarily mean that it stands on solid ground. So let us take a look at the facts. Okay, so I think from here, he's going to go into this electrical theory of matter and the history of that. I think that was a good summary of the nuclear theory of matter. By the way, Larson's first book, which is not necessarily really about the reciprocal system. And it's a book that I have not... I think a couple episodes ago I did say that I have read all of Larson's books. I have not read this first book, which is called The Case Against the Nuclear Atom. And this book really, I think this was part, this is kind of like what we just looked at today is kind of a summary of what he talks about in that book, I think. It doesn't really get into the reciprocal system at all. It's really kind of a refutation of legacy science as it stood back in 1959. I intend to read that book at some point, but I have not yet. In today's section, we just kind of covered that refutation of the nuclear theory of matter. And I think then tomorrow he'll be getting into the electrical theory of matter and just kind of demonstrating, do we really know this or not? I think it's a good exercise in humility for us as Westerners to kind of look at our bedrock philosophies and recognize whether it's the nuclear theory of matter or whether it's something else, whether it's something having to do with religion or philosophy or science or history, that there's a lot of mystery out there. And when we are so positive about our state of understanding of things, we probably are overstating the case, and we probably are doing it because we're being manipulated to do it. And we probably are missing out on quite a lot by doing it. So I think it's good to just keep all that in mind. And I appreciate you tuning in today. And tune in tomorrow where we go over the next section of this paper. Otherwise, have a beautiful day.